Okay, this final video for the completing the square part of the lesson, and there will be additional videos for converting into vertex form, which is an application of completing the square, to follow that will be added to this list once we complete that lesson. So what this video is going to do is cover the last two examples from the notes, examples E and F, and then it will talk about the extension question, which is, okay, all 6 examples we looked at, all 7 examples that we looked at, had the same properties. They were all very simple. They all had an A value that was equal to 1. They all had a B value that was even. What happens? How does this work if that's not the case, if we have a harder problem? So on an E, we need to again remember that we have a certain format that this has to be in for us to start. It has to be in the form x squared plus bx equals c. So our first step is to move the 41 to the right side by adding 41 to each side of the equation. That will give us x squared plus 4x equals 41. Once it's in the correct format, we're going to add our blanks and actually carry out the process of completing the square. So 4 is our b value. Again, that process is we're going to divide 4 by 2, which is 2, and fill the bottom blank. Then we are going to square 2 and write that in the top blank. This completes the perfect square trinomial. However, by adding 4 to the left side, we have unbalanced the equation. So to solve that problem, we then copy that 4 over to the right side to rebalance the equation, because whatever I do to one side of the equation, added 4, I have to do to the other side of the equation to keep it balanced. Now I simplify the right side. 41 plus 4 is 45. This has turned the original problem into a problem that I already know how to solve using square root method. So I take those binomials, or the two sides of that equation, those squares, and I take the square root. When I take the square root of a binomial squared, all it does is cancel the exponent, leave me with x plus 2. On the other side, the square root of 45, my calculator again can reduce it for me, but I need to remember to put my plus or minus in there. 45 breaks into 9 times 5, meaning it reduces to 3 root 5. But there are still 2 roots, a positive root and a negative root. So if I forget the plus or minus, I'm only providing half the answers. And if I only provide half the answers, I should only expect to get half the points. Subtract 2 from each side to finish the problem, and we get x equals negative 2 plus or minus 3 times the square root of 5. Now again, I've gotten this question all the time. I'm okay with, although I'm not super thrilled because it doesn't look right to me, the answer plus or minus 3 root 5 minus 2. That is technically the same thing and is not a problem. Same thing on letter F. We need to move the 13 before we start so that we're in the correct format. That would be x squared plus 10x equals negative 13. Insert your blanks. Divide b by 2 would be positive 5. Square that value would be 25. Copy it to the other side would be 25. Negative 13 plus 25 is 12. So I have turned that into x plus 5 quantity squared equals 12. I'm going to take the square root of each side, which will give me x plus 5 equals plus or minus 2 root 3. I'm then going to subtract 5 from each side of that equation. Again, those cannot be combined. They're not like terms. So the best I can do is negative 5 plus or minus 2 root 3. And again, I would technically allow, but I'm not excited about you writing that as plus or minus 2 root 3 minus 5. So now we've got 7 examples in our notes of problems that work out nicely. So the question arises, okay, those worked out pretty nicely. What if A doesn't equal 1? What if B is not even? What if it's odd? Well, that doesn't change much. All it does is introduce the dreaded fraction to the situation, because our steps are still the same. We need this to be in the specific form x squared plus bx equals c. That means we have to have a 1 in front of x squared. The rest of that, b and c, could be any real number, and this process will still work. So, we need to do two things to this equation to set it up for completing the square. The first is to subtract 67 from each side, which would give us 2x squared minus 5x equals negative 67. And I didn't leave room for the blanks yet because we're not ready to add the blanks yet. This is not in the correct format because we still have a number in front of x squared. We can't have that. It has to be a 1. So what we do is we divide it by 2. Well, if we divide it by 2, we have to divide everything by 2. Now let me be clear. In my class, if you turn 5 over 2 into a decimal, the problem will be marked wrong immediately, because not using fractions is setting yourself up for failure. Fractions make calculations in Algebra 2 much simpler. You need to get over your hatred of them from junior high and get comfortable with using them, or you are going to have a very, very hard time advancing in algebra class. So we're looking at x squared minus 5 halves x equals negative 67 over 2. We need to insert our blanks, one on each side and one below. And I shouldn't have put a minus there yet because the sign on that depends on b. This process is still exactly the same. We just have fractions. So we still are going to take our b value, negative 5 halves, and we're going to divide by 2. That would be negative 5 over 4. Then we're going to take that value, just like we did before. Absolutely nothing has changed in terms of steps, and we're going to square it and write it in this up here. Negative 5 over 4 squared is 25 over 16, because when I square a fraction, it's like squaring the bottom and squaring the top. 5 squared is 25, 4 squared is 16. And then I need to copy that value across to the other side. So I should be adding 25 over 16 to the right side. Now the part that always seems to mess kids up nowadays is you're going to go and you're going to put this part in the calculator. And what your calculator is going to do is it's going to take that problem and it's going to calculate its answer. And the way that it does that is it gets a common denominator, which would be 16. So it has to multiply the bottom of the first one by 8. Whenever it does the bottom, it has to do the top, which turns this into negative 536 over 16 plus 25 over 16. And then you add the top numbers, which would give you negative 511 over 16. Now the reason for this being such an ugly number is twofold. One, I wanted to establish that this works for every number. Every number you can use completing the square. It's not always going to be pretty. The other reason it's on there is because I want to establish that your calculator is not your brain. You can't always trust it to do the work for you. If you put that number, negative 511 over 16, into your calculator, and you take the square root, as is the next step, x minus 5/4 squared equals negative 511 over 16. And you take the square root of that, your calculator, no matter what calculator you're using, is going to tell you there's a domain error. That's because that number is negative. And to this point, you have never taken the square root of a negative number successfully. It can be done. And we're going to talk about that in a later lesson. So essentially what I want you to do for now is, oh, it's negative. We're just going to ignore that fact. Okay? That negative is going to generate an imaginary number in front of our square root. Now, even if we ignore the negative, if we put that in our calculator as 511 over 16, it's still not able to handle that. It's still going to print a decimal. I don't want decimals. Use your brain. The square root of a fraction is the square root of the top over the square root of the bottom. Everybody in my class should be able to tell me that the square root of 16 is 4. So you shouldn't need to put the over 16 into your calculator. You should just need to put in root 511. So we put in second root, so a second x squared to get the root symbol, 511, and we hit enter. And guess what? It doesn't reduce, so we just leave it as root 511. On the other side, all that happens is the exponent cancels. So then our final step we need to move the 5/4 by adding 5/4 to each side, just like we always do. Move it up here because I'm out of space. That will give us x equals 5/4 plus or minus I root 511 over 4. Now, would I suggest that you use completing the square on this problem? I wouldn't. I very rarely use completing the square, especially for problems where there's a negative discriminant. I would probably do quadratic formula here, but again, I'm further trained in Algebra 2 than any of you are so far. In a couple lessons, problems like this will not be a problem at all for you. So let's take a look at one more hard example where the answer is not quite as ugly. Here is another quadratic. We need to put it in the correct form. So again, in order to be in the right form, the x term is on the wrong side, so we need to add 8x to each side. And the 4 is on the wrong side, so we need to subtract 4 from each side. That will change this into 3x squared plus 8x equals negative 4. Now again, that form does not allow a number in front of x squared, so we need to divide everything in this problem by 3. That will give us x squared plus 8/3 x, and then we're going to go ahead and insert a blank, equals negative 4/3 plus something. And we're going to carry out completing the square because now we're set up and in that form. We take b, we divide by 2. 8/3 divided by 2 is 4/3. Then we're going to take 4/3 and we're going to square it and write it in the 2 blanks above. That would be 16 over 9, which we then copy to the other side, 16 over 9. Now again, when we put this in the calculator is going to say, oh, negative 4/3 plus 16/9. I need a common denominator, and it's going to get one by multiplying the bottom and the top of the first fraction by 3, which would be negative 12/9 plus 16/9, or 4/9. So this is equal to 4/9. So we have x plus 4/3 quantity squared equals 4/9. That's a square root problem. So we take the square root of each side, which gives us x plus 4/3 equals plus or minus 2/3. Because the square root of 4 is 2 and the square root of 9 is 3. Subtract 4/3 from each side, and we get x is negative 4/3 plus or minus 2/3. Well, those can be combined. So just like the problems earlier in the lesson, we're going to have to separate those out. So negative 4/3 plus 2/3, that would be negative 2/3. And our second answer, x could be negative 4/3 minus 2/3, which would be negative 6/3, which reduces to negative 2. So our answers are x equals negative 2/3 or x equals negative 2. So as you can see, completing the square is a very powerful tool. It will always work. Now we still have more to this lesson. We still have to do a video for converting from standard to vertex form and the information that we can pull from both of those forms, as well as graphing and solving by graphing. And I would like to, in the very last video on this playlist, show you where the quadratic formula comes from using completing the square. So stand by and watch for 2 to 3 additional videos added to this playlist at a later time.